Alright, let's look at the homework 2.6, problem number 6. Alright, it says that the function is a ratio of quadratic functions. So you have a quadratic function on top and the quadratic function on the bottom. And then it has a vertical asymptote. Alright, so let's start writing stuff. Alright, so we know that the f of x is going to have, right, vertical asymptote at x equals 9. So we're going to have a factor x minus 9 on the bottom to have a vertical asymptote. Right? It says that the one x-intercept, which is x equals 4. So in order to have a x-intercept, the numerator has to become 0, right? So you have a x minus 4, right? So we have that. And known that it has a removable discontinuity, which means that at the x equals -1, so we would have x plus 1 on the bottom, at the same time x plus 1 on top. Right? And the limit has to be equal to 5. Right? So you can see that if you take the limit of this function as x approaches -1, so where would that go? Right? So let's do that. So if you take the limit of, let's just say, this function, might not be the correct one, so we have to make an adjustment if it's different. So you have, if you take the limit of this function as x approaches -1, right? So as usual, we can cancel the common factors. Then you basically plug in. Right, so you have, we end up getting -1 minus 4, so it's a -5 on top. Right, then here you have a -9, so it's going to be -10. Right, so this is going to give us, let's say, divide through, so it's a 1/2, so it's a 1/2. Right, so we're going to get the 1/2 instead. Right. So what we want to do is we want to get 5 instead, right? So we just need to multiply by 5. So what we're going to do is I'm going to put 5 here, which means that this is going to be 5 times that, which means that, actually, sorry, I messed that up. It's not 5. It has to be 10, right? So we'll have to do 10. And then multiply by 10, and then multiply by 10 will get you the 5 that we want. Right, so the formula is going to be this guy right here. So I just have to put 10 right here. Right, so let's find the f of 0. So f of 0, plug in 0, so it's going to be 10 times 0 minus 4, so it's a -4 times 0 plus 1 times 1 over, right, 0, so it's going to be -9 times, of course, 1, right? So 1 really doesn't do anything, so, and the negative sign goes away, so you have a 40 over 9, right? So 4 times 10 is 40 over 9, right? So 40 over 9, right? Let's type it in. We're going to have 40 over 9. Right, let's go ahead and check the answer. Alright, I came back. Looks like we got part A correctly. Right, let's do part B. So we want to take the limit as x approaches positive infinity. Right, so we can easily do that. So you have a limit as x approaches positive infinity. So it's a 10 x minus 4 times x plus 1 over x minus 9 and then x plus 1, right? We can go ahead and cancel the common factor because it's not going to make any difference, right? Then we can use the trick. Let's use the trick. So you have a polynomial degree 1 on top, and you have a polynomial degree 1 on the bottom. And then leading coefficient is 10 over leading coefficient is 1. So it's going to be 10, right? But I'm going to use the trick, right? So I'm going to divide top by x and the bottom by x so that we can find the limit. So this is going to be a limit as x approaches infinity, and then you're going to have 10's 10. Right, x divided by x is going to be 1. Negative 4 divided by x is negative 4 over x. And the x divided by x is 1. Negative 9 divided by x is negative 9 over x. Right, then you know that 4 over x is going to approach 0 as x gets larger and larger. Same thing happens to 9 over x as that's going to approach 0. So what's left is 10 times 1 over 1, so which is going to be equal to 10. So answer for that is 10. Right, so let's type it in. Right, answer is 10. Right, let's check the answer. Alright, I came back and looks like we got this one correctly as well. Alright, that's it. I hope that this was clear.